My name is Surojit Sarkar. I'm a principal investigator at the Bentown Center for Childhood Cancer Research at the Seattle Children's Research Institute. And I'm also a faculty member at the University of Washington School of Medicine in the Department of Pediatrics and Pathology. My laboratory largely works on developing novel cancer immunotherapies to solid tumors. To understand what I work on, I would give you a little bit of a background in immunotherapy. Immunotherapy has seen unprecedented success in the recent years in the treatment of cancer. The immunotherapy largely deals with two broad arms, one where we can inject a drug inside a patient and that goes in and bolsters the immune system or the cells of the immune system to fight either a pathogen or cancer. Or the other arm of it deals with taking the immune cells out from a patient, engineering them and putting them back in, sort of in ultra-evolutionizing them or empowering them to go in and do their job better than what they were supposed to do. Immunotherapy has seen unprecedented success in the recent years, especially in the field of leukemia, where we're seeing upwards of 90% of success rate in curing refractory leukemia in pediatric cancers. But when it comes to solid tumors, it's a completely different game. Solid tumors, to begin with, are very different compared to liquid blood tumors, which are accessible in the liquid phase in the three-dimensional space. Solid tumors are layers of these tumor cells, which are tightly wound up in the shape and size of a golf ball sometimes. And not only they are very hard to kill because these immune cells get very tired killing these layers and layers of these tumor cells, but also the inside of this tumor microenvironment is highly hypoxic. In other words, it is suffocating. There's very little oxygen, very little nutrients inside the space, which are things that your immune system, cells of your immune system, the fighters, sort of need to kill the cancer cells. So the cancer-fighting engineered cells, when we put them in, they can do the job for a short amount of time, killing a few layers of the tumor cells from outside, even in a golf ball sized, and even in a quarter-sized tumor where it could be billions and billions of cells, but it gets very quickly tired and so-called exhausted. So it's akin to a marathon runner, think of it, or a soldier, marathon runner running like many marathons in succession, or a soldier fighting battle after battle without any rest. So these cancer-fighting T cells get very tired quickly and ineffective, so to say. We are tremendously excited with this grant from Pediatric Cancer Research Foundation. This will enable us to engineer novel ways to rest these soldiers so that they can recharge and fight the tumor cells again. When I was a kid, I didn't play much video games, but my peers used to, and I used to see that during these fighting games, there will be this energy bar or energy meter for the fighter. As the fighter fought against the enemies, the energy meter will start coming down, and at a point when it's too low, the fighter is defenseless. So the idea for us would be to sort of incorporate a genetic code within the cancer-fighting immune cells so that we can turn these fighters that are fighting and have exhausted their energy meter, so to say, so that they can sit and recharge that energy meter without the fight, without the enemy, without sensing the enemy around them, so that they're ready to fight again. And the way we are going to do this is that we're going to use a genetic code which can be used to turn these cancer-fighting immune cells on and off simply by giving a small innocuous molecule in a pill. So when they take the pill, on meaning fight state and off meaning rest state. So the idea here is that not to give the cancer cell a rest when our soldiers are in an off state. We're going to put in another population which is going to fight, which is technically going to be inside the patient and is going to be fighting so that one population is in an on state. It's going to continuously fight the tumor cells while the other population is recharging and getting ready to fight. Now this population is ready, whereas this population is ready to rest. So now this population goes to fight, this population rests, builds up the energy meter, and the cycle goes on. So this will give us a tremendous advantage, I think, from the point of view of the cancer-fighting cells. The tumors won't get that advantage because they will see an incessant, continuous fight from the point of view of the immune system, which will be continuously fighting it. So again, I want to thank the Pediatric Cancer Research Foundation again for supporting this novel idea. We hope to use this to revolutionize and bring in new cancer immunotherapies to children in the future, and hoping that it will be a step forward in the field of cancer immunotherapy for pediatric cancers. Thank you.